Okay, class, we're going to talk about some properties that we've seen before and really haven't used of similar triangles. And the property we're going to talk about today is the triangle proportionality theorem. And what this theorem says is if you do have two parallel lines in a triangle, so I'm going to highlight these guys. So these two lines are parallel. What this theorem says is the sides that they intersect, so these sides in purple, they get split proportionally. So those purple sides will get split proportionally, which means we can take these sides and create fractions out of them. For example, because of this theorem, we could then say RT, which is this guy, makes a fraction with TQ, and will be equal as a proportion with RU over US. Okay, and now that we have this theorem, we can easily solve this proportion. In the past, we had to redraw the triangles. Now with this theorem, we can do it a little faster, as I will show you in example B. So in the past, we would have to redraw these like so. So I would go here, this would be M, N, P, and then we would put in 9 here, 6 here. And then we draw the overlap. So we draw the bigger triangle. And this one would be M to Q to R. Okay, and we would put M to Q, which would be M to Q, would actually be 6 plus 4, which is 10. Okay, and our job in this example would be to try to figure out what is N to R. So our goal would be X. So what we would have to do is M to R would be, from M to R would be 9 plus X. Okay? And then we would have to match sides and set up a proportion. So it would look something like this. So we'd go 9 over 9 plus X equal, so 9 matches with 9 plus X, so 6 would match with 10. And to solve this proportion, or to solve for X, which is NR, we would cross multiply and solve. So this times this would give me 6 times 9 plus X equal this times this, give me 90. And then to solve for X, we would distribute, and of course you've done this before, hopefully you remember. 6 times 9 is 54 plus 6X equals 90. And we would continue to solve this out. So 54 plus 6X equals 90. Subtract 54 from both sides. Would equal 6X equal to 36. And then divide by 6. And we get X, which is actually an R, equal to 6. So in method 1, we would get NR, which I labeled X, equal to 6. Now in method 2, using this theorem, it's a little faster. As long as these are parallel, we can use what is also called the side splitter theorem, the triangle proportionality theorem, that says we can then make just a quick proportion. 9 over x, so basically the same sides that get split. So 9 over x is equal to 6 over 4. Again, this is using the side proportionality theorem. Cross multiply, 6x equals 36. Divide by 6, and x equals 6. We get the same answer for x. Again, this theorem here, method 2, is using triangle proportionality theorem. Okay? In the past, we had to split it up and do all this work, but now because these lines are parallel and we have overlapping triangles, we can now do this theorem. All right, let's practice some more. Okay, so in example C, what is the length of EG? Again, I'm going to use the side proportionality theorem. So EG, real quick, I'm going to mark that from E to G. I'm trying to find that. So to use the side proportionality theorem, I'm going to label this missing side DG as x. Once I find x, I'm just going to add it to 40 and it will give me E to G. So the side proportionality theorem can work here because these sides are parallel. So I'm going to go 32 over 24. So 32 over 24 is going to be equal to 40 over x. And now we can just cross multiply to solve. 32 times x is 32x. 24 times 40 equal to 960. Divide by 32. X is going to equal 30. Keep in mind, this is not my answer. This is x. I'm trying to solve for EG. So instead of x, I now know DG is 30. So if DG is 30, EG is equal to 70. Because I just added 40 plus 30. All right, we also can use the side proportionality theorem another way to prove sides parallel. In order for these two sides to be parallel, then these sides that are split should be proportional. So let's check. So I'm going to set up 21 over 42. And then I'm going to set up 15 over 30. What I want to check is, are these two fractions actually equal to each other? So I'm going to reduce both of them to see if they come out to the same fraction. All right? So this guy can be reduced by 21, which gives me a fraction of 1 over 2. So the first fraction is 1 over 2. Now I want to reduce the second fraction. I can reduce by 15. And this gives me 1 over 2. So I have just shown that these two fractions are actually equal to each other, which makes them proportional. And because they're proportional, the only way they can be proportional in this situation is if KL is parallel to MN.